Welcome to my video. I have completed from question number 1 to 13 in my previous video, and now I am going to do from question number 14. So here question is given to prove A dot A cross B is equal to 0. So first we have to take this bracket term, which is our A cross B, A vector cross B vector. Okay, so as it is a vector product, so we can write it as AB sin theta into n cap, where theta is angle between A and B vector and n cap is a unit vector which is perpendicular to the plane which contain A vector and B vector. Plane contain A vector and B vector. Like this, if I draw in picture, so let this is a plane where let this is a vector and this is B vector, this is A vector, and so n vector is perpendicular to it, means above the plane. Okay, so we can say that n vector now perpendicular to A vector from the figure, and also n vector is perpendicular to B vector. Okay, now let denote this term as C vector, because as it is a vector product gives a vector, so we consider another vector which is C vector. So now our equation is become A vector dot C vector. So let, as it is a dot product, so it will become A C cos, let this angle between A and C is theta dash, let we denote as theta dash. So here C vector direction is n vector direction, and we have written here that n vector is perpendicular to A vector, so this theta dash now become 90 degree. So we can clearly see from this image also. Okay, so we can denote it as AC cos 90 degree, so which is cos 90 value as we know 0, so it will become 0. So hence we prove A vector dot, in place of C vector we can write A cross B vector is equal to 0. Okay, so we have also another method we can prove by taking, as it is a scalar triple product. By determinant form we can denote, we can prove that this vector scalar triple product is 0. Like by taking, let A vector is, or another method, let A vector is, we consider Ax I cap plus Ay j cap plus Az k cap, and B vector is B vector is, we can write it as so B vector we can write Bx I cap plus By j cap Bz k cap. So we know A cross B can be written in the form of determinant as this I cap j cap k cap. So here is, first I write the A component, Ax, Ay, Az. So B component is Bx, By, Bz. Okay, so its value become I cap I cap into ay bz minus az by az by az by plus j vector into denote az bx minus ax bz plus k cap into whole into ax by minus ay bx. So this is our a cross b. So now a dot a cross b, if we write, then as we know, we just in dot product we just write the similar component in the product form, like as it is ax whole into ay bz minus az by, okay, because then it's ay into az bx minus ax bz plus az whole into ax by minus ay bx. If we multiply all these vectors, sorry, all these components, then it will get cancelled with each other and it will become 0. So it's proof. Okay, so now the next question. So our next question is question number 15. It's a very simple question. So it is asked to find just a cross b, that is vector product, as we have done here now. So I can write it as ax plus a vector plus b vector. So first I j k. So first I will write component of a. The x component is 2, y component is 3, z component is 4. So now the b component of b vector is 4. So x component is 4 and its y component is 3 and its z component is 2. So simply determinant we have to find. So now it will become simply I cap all into 3 into 6, 3 into 2 is 6 minus 4 into 3 is 12. So plus j vector 4 into 4 is 16 minus 2 into 2 is 4 plus k vector whole into 2 into 3 is 6 minus 4 into 3 is 12. So if we simply calculate, we get minus 6 I cap, okay, plus 12 j cap minus 6 k cap. So it is a very simple question. I think there is no doubt. Okay, so next question is, now our next question, question number 16. Question number 16 is this: if a vector, b vector, c vector are mutual perpendicular, so that c cross a cross b is equal to 0 and its converse also true. Is the converse is true? We have to. So is the converse is true or not, or it is false? So first it is showing a, b, c are mutual perpendicular to each other. Take all the vector in x, y, z direction. So let this is one vector, this is, and this is our, okay, this is perpendicular to this plane. Okay, so now let's denote this is a vector, this is B vector, this is a C vector. Okay, so first we have to show that this is a, the product of this is 0. So bracket term is A cross B. So we have already known it, this is a vector product, so its result is AB sin theta. Theta is angle between AB and V, and its n cap. N cap is perpendicular vector, a unit vector which is plane which contain both A and B. So we can say that if this is X and this is Y axis and this is Z axis, so n cap direction is along Z axis. It may be, I don't know, it may be in the direction of Z axis or in opposite direction of Z axis. So we can say that the angle between C vector and A cross B vector, or simply we can say N vector, either 0 degree or 180 degree. So what it may be, but the resultant is, if we taking cross product C vector into A vector cross B vector, so is equal to, we can write C A cross B, we did not let this is a D vector, so we can write simply CD sin theta dash let into N vector. So as theta is, this angle between this is either 0 or 180, and the sine value of 0 and 180 is 0, so this will become 0. So we prove that C vector cross A vector plus B vector, if A cross B cross C is mutually perpendicular to each other, then its resultant is 0. Now you have to show its converse, means if this is 0, is these are mutually perpendicular to each other or not, we have to prove. So how we prove? So let are given is this. Okay, so from this we can conclude that C vector is perpendicular to the plane which contain A and B. That means it does not require that A and B V are perpendicular to each other. It does not require that A and B perpendicular to each other. It may be that angle between that less than 90 or greater than 90, but when we take the cross product, its vector is perpendicular and which is in the direction of C vector, so like this, and it will become 0. So its converse is not true. So its converse is not true. Understand? Okay. So our next question is question number 17. Okay. So our question number 17 is given that let a particle on a given straight line which is at a constant speed v, this is v vector, sorry, as this is a speed given, so it is in magnitude. Okay. At a certain time, at a point P on a straight line path, let the point is in this, it moves in a straight line, let this point is let A. Okay, so O is a fixed point, let this is O, this is a fixed point. So at a certain time, let this is the P point, point P, this is point P. sorry, this is, let this is point P. This is perpendicular, let, and this is the angle between this. The body is moving in this direction. Okay. Okay, now let this angle is theta. Okay. So the question is, we have to find OP cross B. OP vector, let this is OP vector, this is B vector. So angle between them is theta. Okay. So OP cross B vector, we can write as OP, sorry, it's in, so it's OP dot V, it's sine theta into n cap. N cap is unit vector direction. So we can write it as V into OP sine theta into n cap. From this triangle OAP, triangle OAP, this is base, this is perpendicular, this is hypotenuse. So we can found that sine theta is P by H, which is OA by OP. So that implies OA is equal to OP sine theta. Right? In place of OP sine theta, I can now put OA. So it's V dot OA into n cap. Okay. So let, after some times, the body is at this direction, at this point. Let this is P dash. Okay. So the angle between them is, let theta dash. Now, if we calculate the same process, OP dash vector into V dash. So in this way, I'll write the same way. So it will become V dot OP dash sine theta dash n cap directions. Also in from now, from the triangle OAP dash triangle, same way we can find OA is equal to OP dash sine theta dash. So we put here V dot, in place of OP sine theta dash, we just put OA into n cap direction. Look here, if we take point P here P dash, but the answer is same, B dot OA n cap direction and B dot OA n cap direction. So from this we can conclude, or we can say that the product of this term is independent of P, point P. Okay. So OP vector cross B vector is independent of position of that particle P. Okay. So conclude. Now the next question. Next question is question number 18. Okay. So question number 18 is saying force on a charged particle due to electric field and a magnetic field is given by F is equal to QE plus Q into B cross B vector, where E is in the X direction, okay, and B is in Y direction. Okay, so let this is X axis, so here is E vector is in this direction, and let this is Y axis, so B vector is in this direction. Okay, so question is given, in what direction, with what minimum speed V should a positive charge particle to be sent so that the net force on it is 0. Okay, so we have to first solve. Let F is equal to 0. So we can write in place of F, it is given that Q E vector plus Q whole into V cross B vector is equal to 0. Simply we can write here E vector is equal to minus V cross B. That means we can say that V cross B is in opposite direction of this minus sign, indicates that V cross B is in opposite direction of E vector. That means in negative x-axis direction, that is in this direction. Okay, so as it is in negative x direction, so we can say that V and B vector both are vector which must be in, it is in negative x direction, so we can, there must be in yz plane. Okay, so must be in yz plane. Now another things. So we can simply now solve E vector is equal to, we can write it as VV sin theta. We take just its magnitude. Okay, now we find E is equal to V cross V, VV sin theta. To find V minimum, so V is equal to with E by B sin theta. So, okay, for V minimum, okay, for V minimum we can say sin theta for V minimum sin theta must be equal to 1 as it is in denominator. Okay, sin theta is equal to 1, that means theta is equal to 90 degree. Okay, so that is like, now magnitude of V become E by B. So as we find that the magnitude of V is E by B. Now we have to find its direction. So already we have found that, we have done here that V vector must be laying in the yz plane. And now here we find that V vector is angle must be theta is 90 degree. So we can say simply that V vector must be in the direction of z vector. Okay, if V vector is in the z direction, then V cross V must be equal to 0. If V cross V is equal to 0, then the net force F will become 0. Otherwise it will not be 0. Okay, so this term will become 0 and this term also become 0. So in total we can say net force is 0. Okay, so here we conclude. Thank you. Bye. We'll meet in our next video.